June 4th, 1944. A cold, damp tent on the southern coast of England. Outside, the relentless English rain drummed against canvas, while inside, Colonel James Thornton stared at the aerial reconnaissance photos spread across a wooden field table. The images revealed the distinctive patchwork landscape of Normandy's Bocage country, ancient hedgerows forming a natural fortress that would soon become a killing ground for American tanks and their crews. Thornton's weathered face betrayed no emotion, but the tremor in his hand as he reached for his coffee cup told a different story. After months of preparation for Operation Overlord, after years of industrial mobilization and strategic planning, after countless lives already sacrificed to bring Allied forces to the brink of Europe's liberation, they had overlooked something devastatingly simple: the hedgerows. Between him and his engineering officer, Major Robert Calloway, lay reports from terrain specialists, agricultural surveys, and topographical maps of the Norman countryside. The information they contained wasn't classified or hidden. It was mundane, known, predictable. Yet its military implications were catastrophic. The ancient hedgerows of Normandy, some dating back 1,000 years, would turn the American armored advance into a slaughter. "This isn't just difficult terrain," Calloway said, his voice barely above a whisper. "This is a perfect defensive network that the Germans have had 4 years to prepare for. Every field is a fortress, every hedgerow a wall, and we have nothing, absolutely nothing, that can break through efficiently." The hedgerows of Normandy were unlike anything American forces had trained for. Standing 4 to 8 feet tall, they weren't simple rows of bushes but earthen berms topped with centuries-old vegetation, dense, tangled barriers of hawthorn, blackthorn and oak with root systems that had intertwined for generations. Each formed the boundary of a small field, creating a maze-like network across the countryside. Aerial photos showed thousands of these enclosed fields stretching for miles inland from the beaches. "When our tanks try to climb these berms," Thornton said, pointing to a cross-section diagram, "they'll expose their vulnerable underbellies, perfect targets. And the moment they breach a hedgerow, they'll be silhouetted against the sky for every German gunner in the next field." The realization that had brought these men together in this tent was spreading through the Allied command structure like a wave of ice water. The Americans had prepared for every aspect of the invasion they could imagine, except how to move armor effectively through terrain that nature and a millennium of French farmers had transformed into a defensive network more effective than any concrete fortification. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The journey to this moment of terrible clarity had begun months earlier with the initial planning for Operation Overlord, but its roots stretched back to fundamental miscalculations about the Norman landscape. Allied intelligence services had mapped the region extensively, identifying German fortifications, plotting artillery positions, and analyzing beach defenses. But they had catastrophically underestimated how the ancient agricultural system of the Bocage would impact mechanized warfare. This wasn't mere incompetence. The assumptions built into Allied battle plans, shaped by experience in the North African and Italian campaigns, made the hedgerow country seem navigable, even advantageous for providing cover during the advance inland. American training exercises had taken place on the rolling fields of England or the deserts of Arizona, nothing resembling the compartmentalized battlefield they would soon face. By June 1944, the United States had mobilized, its industrial might to an extent that dwarfed anything in human history. American factories were producing tanks, planes, and ships in quantities that made German production look like a cottage industry. The M4 Sherman tank, the backbone of American armored forces, was rolling off assembly lines at a rate of over 1,500 per month. Fast, reliable, and produced in overwhelming numbers, the Sherman seemed the perfect vehicle to spearhead the liberation of Europe. But the Sherman had been designed for open warfare, for the desert expanses of North Africa and the rolling plains of Central Europe. Its high profile and vertical front armor were catastrophic weaknesses in hedgerow country, where German anti-tank teams could set up ambushes in each tiny field. The Sherman's belly armour was too thin to protect against mines when it climbed the steep hedgerow banks, and its gun couldn't be depressed enough to fire down into the next field before cresting the barrier. When presented with detailed analysis of the terrain problem, General Omar Bradley, commanding the U.S. First Army, was reportedly stunned. "You mean to tell me that 4 years into this war, with all our industrial might, with all our engineering expertise, we don't have a solution for overgrown French hedges?" The gravity of the situation became clear as invasion planning progressed. Each Norman field was like a miniature arena, surrounded on all sides by nearly impenetrable barriers. German forces had spent years fortifying these natural defences, cutting firing ports through the vegetation, concealing anti-tank guns, and pre-sighting artillery on the likely breach points. The bocage was a defender's dream and an attacker's nightmare. Initial American approaches to the problem were mechanical and predictable. Engineers suggested deploying bulldozers to clear paths, but these slow, unarmoured vehicles would be priority targets for German gunners. Artillery officers proposed saturating each field with shells before advancing, but this would slow the advance to a crawl and telegraph each movement. Some planners even suggested avoiding the bocage entirely, but geographical reality made this impossible. The hedgerow country stretched for miles inland from the landing beaches. The depth of the miscalculation became apparent in the final weeks before D-Day, but by then it was too late to fundamentally alter plans or equipment. The invasion would proceed, and American tankers would have to find a way through the ancient agricultural maze with the tools at hand. Many officers privately estimated casualty rates as high as 75% for the leading tank battalions. Major Calloway, whose engineering background included both civilian construction and military demolition, had been tasked with finding solutions. As D-Day approached, he worked around the clock, testing various approaches on mock-ups built behind the Allied camps in England. Nothing proved both effective and practical under combat conditions. "The problem," he explained to Thornton that rainy night in England, "isn't that we can't break through a hedgerow. We can blow them up, burn them, or push through with enough force. The problem is doing it quickly, under fire, without exposing our vehicles and men to unnecessary risk." Calloway's team had created detailed models of the Norman hedgerows based on French agricultural records and resistance intelligence. The mock battles they conducted produced consistently grim results. Sherman tanks attempting to breach the barriers became stuck, exposed their vulnerable underbellies, or burst through only to be immediately destroyed by waiting anti-tank teams in the next field. "Our tankers will learn," Thornton said, though his voice lacked conviction. "They'll adapt, develop techniques. They'll die learning," Calloway responded bluntly. "The first wave will be sacrificial. We both know it." The burden of this knowledge weighed heavily on both men. They understood that thousands of young Americans would soon face these deadly obstacles with inadequate equipment and training. Many would not survive the learning process. On June 6, 1944, Allied forces landed on the beaches of Normandy. The amphibious assault, though costly, succeeded in establishing a foothold in Hitler's fortress Europe. American, British, and Canadian troops pushed inland, and within days, the Americans found themselves confronting exactly the nightmare scenario that Thornton and Calloway had predicted. The progress of American armour slowed to a crawl as they entered the Bocage country. Standard Sherman tanks attempting to climb the hedgerows exposed their thinly armoured bellies to German anti-tank weapons. Those that managed to breach a barrier were often immediately destroyed by weapons waiting in the next field. Tank commanders reported losing multiple vehicles to claim each tiny Norman field. The tactical challenges proved even worse than anticipated. Each field became an isolated battlefield where American advantages in air power and artillery were negated by the close quarters and limited visibility. German defenders, familiar with the terrain after 4 years of occupation, had prepared interlocking fields of fire. Anti-tank teams could retreat through pre-cut paths in the hedgerows, while American tanks had to expose themselves to cross each barrier. Within the first week after D-Day, American tank battalion commanders were reporting casualty rates approaching 60%. The hedgerows were exacting a terrible toll in American lives and equipment. Even more concerning, the advance inland was falling behind schedule, threatening the entire Normandy campaign. Sergeant Curtis Culin of the 102nd Cavalry Reconnaissance Squadron found himself in the thick of this deadly puzzle. A former mechanic from Chicago with no formal engineering training, Cullen had watched 3 tanks in his company destroyed while attempting to breach a single hedgerow near Street Low. The sight of his fellow soldiers burning in their vehicles haunted his nights and drove him to seek a solution. "There has to be a way through," he told his company commander, "not over, not around, through." Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. The breakthrough began not in the elaborate planning rooms of Allied headquarters, but in the mud and blood of the Norman countryside. Tankers and infantry on the front lines were developing their own field modifications and tactics, driven by the primal need to survive. Some units began using demolition charges to blow gaps in the hedgerows. Others tried pushing trees over with the weight of their tanks, and some even attempted to cut passages with saws and axes under enemy fire. None of these approaches solved the fundamental problem: the Sherman tank's tendency to expose its vulnerable underside when climbing the steep hedgerow banks. It was this specific challenge that occupied Cullen's thoughts as he scavenged through a captured German supply depot in late June, looking for anything that might help his unit survive. What he found was a pile of steel beach obstacles, metal barriers the Germans had placed on the Normandy beaches to rip open the hulls of landing craft. Known to the Allies as Czech hedgehogs, these were welded angle iron obstacles about 3 feet high. As Cullen later recalled, "I was staring at these steel crosses, thinking about how they were designed to tear things open, when it hit me, what if we used them to tear open the hedgerows instead?" Working with mechanics from his unit and using German welding equipment from the captured depot, Cullen fashioned crude cutting teeth from the steel obstacles and attached them to the front of a Sherman tank. The improvised device resembled the horn of a rhinoceros, a comparison that gave birth to the name Rhino tank. The first test was conducted under enemy fire because there was no safe place to experiment. A Sherman equipped with Cullen's device approached a hedgerow at high speed, its steel teeth ploughing into the ancient earthen bank. Instead of climbing the obstacle and exposing its vulnerable underside, the tank tore through the barrier, emerging into the next field with its armor still pointed at the enemy. Word of the successful breach spread rapidly. Within hours, frontline commanders were requesting details and materials to modify their own tanks. The news reached General Bradley, who immediately recognized the potential of the innovation. Within 48 hours, he had ordered all available welding equipment and suitable scrap metal forwarded to the front lines. What happened next was one of the most remarkable examples of battlefield adaptation and American ingenuity in military history. With no formal engineering plans, no specialized equipment, and under constant enemy fire, American mechanics and soldiers began transforming their tanks into hedge-cutting machines. The initial prototypes were crude, salvaged metal simply welded to the front of Sherman tanks in rough approximations of Cullen's design. But as the process continued, improvements were made. Engineers determined optimal angles for the cutting teeth, welding techniques were standardized, and materials were selected for maximum durability. A fundamental problem in modern warfare had been solved not in research laboratories or industrial design offices, but in the mud of Normandy by soldiers with no formal training in tank design. It was a testament to American adaptability, to the practical problem-solving skills that defined the national character. By early July, over 60% of American tanks in Normandy had been modified into Rhino tanks. The impact on battlefield performance was immediate and dramatic. Fields that had previously taken hours and multiple tank casualties to secure were now being captured in minutes. The hedgerows that had been death traps became passageways, their ancient defensive value neutralized by American improvisation. German defenders, who had spent years preparing their hedgerow defenses, found themselves suddenly confronted with tanks that could breach their carefully prepared positions without exposing vulnerable points. The psychological impact was as significant as the tactical advantage. German infantry reported the terrifying sight of Sherman tanks bursting through supposedly impenetrable barriers, their massive steel tusks tearing through centuries-old earthworks as if they were paper. Major General J. Lawton Collins, commanding the 7 Corps, later called the Rhino tank the most important innovation of the Normandy campaign. In his after-action report, he noted that the modified tanks had reduced casualties by approximately 40%, while increasing the rate of advance by a similar margin. The production of Rhino attachments quickly scaled up from battlefield welding operations to organized manufacturing. The beaches of Normandy became outdoor factories where engineering units worked day and night to modify tanks. Steel from destroyed vehicles, German defenses, and even shipping materials was repurposed into cutting teeth. By the time Operation Cobra, the breakout from Normandy, began on July 25, 1944, nearly 90% of American Sherman tanks had been equipped with Rhino devices. The operation, which had been delayed multiple times due to the slow progress through the Bocage, finally unleashed American mechanized forces across the Norman countryside. What had seemed an insurmountable obstacle just weeks earlier had been overcome through the innovation of a single sergeant and the collective effort of thousands of American soldiers. The hedgerows still stood, their ancient roots undisturbed, but their power to impede the liberation of Europe had been broken by American ingenuity. For Colonel Thornton, who had seen the hedgerow problem coming but been unable to solve it before the invasion, the success of the Rhino tanks represented both relief and a lesson in humility. The solution had not come from the top down, as military planning typically did, but from the bottom up, from the very soldiers whose lives were at stake. Sometimes, he wrote in his personal journal on July 30th, the best thing leadership can do is recognize a good idea and get out of its way. The success of the Rhino tanks rippled through the Allied command structure with the force of a revelation. What had been a seemingly insurmountable obstacle, ancient hedgerows that had stalled the advance and claimed thousands of American lives, had been solved not by elaborate planning or industrial might, but by the improvisational genius of frontline soldiers. The psychological impact on both Allied leadership and German defenders proved as significant as the tactical advantage. General Dwight D. Eisenhower, Supreme Commander of Allied forces in Europe, personally visited the Normandy front in early July to observe the modified tanks in action. Watching a line of Sherman tanks tear through a hedgerow that would have been a death trap just weeks earlier, he reportedly turned to General Bradley and said, "This is why we'll win the war. The Germans build better tanks, but we build better tankers." The story of Sergeant Cullen's innovation spread rapidly through the Allied forces, not just as a tactical bulletin, but as a morale-boosting narrative. Here was tangible proof that individual initiative could overcome even the most formidable obstacles. Frontline newspapers like Stars and Stripes ran features on the Rhino tanks and their creator, celebrating American ingenuity in the face of adversity. For German defenders, watching from their foxholes and bunkers, the psychological impact was devastating. Lieutenant Karl-Heinz Weber of the 352nd Infantry Division later wrote in his diary, "For 4 years we believed the hedgerows would be our salvation, the one terrain feature that would negate American numerical superiority. Now they pass through these ancient barriers as if they were nothing. What else have we miscalculated?" The hedgerow solution represented something fundamental about the American approach to warfare that German military doctrine struggled to counter. While German engineering had produced technologically superior weapons like the Tiger tank and the 88mm anti-tank gun, these advanced systems were often too complex, too expensive, and too few in number to be decisive. American forces, by contrast, excelled at rapid adaptation, pragmatic solutions, and overwhelming production. This pattern repeated across multiple domains of the European conflict. German engineers had designed the Tiger tank with 100mm frontal armor and an 88mm main gun that could penetrate any Allied tank at ranges exceeding 2,000 meters. It was, by most technical measures, superior to the American Sherman, but Tigers were produced in numbers so small, just 1,347 during the entire war, that they became tactical curiosities rather than strategic assets. Meanwhile, American factories had produced over 49,000 Sherman tanks by war's end. They were simpler, less heavily armored, and armed with less powerful guns, but they were reliable, adaptable, and present in overwhelming numbers. When a Sherman was knocked out, another took its place immediately. When a Tiger broke down or ran out of fuel, it was often abandoned for lack of spare parts or recovery vehicles. The Rhino tank modification embodied this distinctly American approach to problem solving, pragmatic rather than perfect, improvised rather than engineered, and accessible to mass production. Within days of Cullen's initial prototype, engineering units had standardized the design and begun mass-producing the attachments using salvaged metal. Within weeks, nearly every Sherman tank in Normandy sported the distinctive hedgerow cutting teeth. Major General J. Lawton Collins, commander of the 7th Corps, recognized the strategic implications immediately. In a memo to General Bradley dated July 15, 1944, he wrote, "The Rhino modification has transformed our tactical situation. Fields that previously required hours and multiple tank losses to secure are now being captured in minutes, with minimal casualties. We are regaining the initiative and mobility that is the foundation of American doctrine." The technical aspects of the modification continued to evolve through July 1944. The initial prototypes, welded together from German beach obstacles, proved effective but prone to breaking under the stress of repeated hedgerow breaches. Frontline engineers began experimenting with different materials, angles, and attachment methods. Captain James Allison of the 747th Tank Battalion introduced a key improvement by adding reinforcing brackets that distributed the force of impact across the tank's hull. This modification allowed Rhino tanks to breach thicker hedgerows without damaging their cutting teeth or the tank itself. Allison's design was quickly adopted across all American armored units in Normandy. Staff Sergeant Michael O'Donnell, a welder with the 25th Armored Engineer Battalion, developed a standardized production process that allowed his team to modify up to 15 tanks per day. Using assembly line techniques adapted from his pre-war experience at the Ford Motor Company in Detroit, O'Donnell organized a mobile workshop on Omaha Beach where tanks could be modified in less than 2 hours. "We set it up just like back home," O'Donnell later recalled. "One team cuts the metal, another shapes it, a third welds it to the tanks. We didn't have a factory, but we had factory thinking." The rapid dissemination of the Rhino innovation highlighted another American strength: the relatively flat hierarchy and open communication between ranks. Unlike the rigid command structures of the German military, where innovations typically required approval from multiple levels of authority, the American system allowed good ideas to spread quickly regardless of their source. Sergeant Cullen, a non-commissioned officer with no formal engineering training, found his innovation championed by generals and adopted as standard doctrine within weeks of its creation. This meritocracy of ideas represented a cultural advantage that extended beyond any single battlefield solution. Colonel Thomas Jenkins, who commanded a tank battalion in the 2nd Armored Division, observed this phenomenon in his after-action report. "The German tanks we faced were technically superior in almost every respect. Better armor, better guns, better optics. What they lacked was the adaptability of our crews and the responsiveness of our system to innovations from the bottom up." As July progressed and more Sherman tanks were modified with the Rhino attachment, American forces began to develop new tactics that maximized the advantage. Rather than approaching hedgerows cautiously as they had in the initial weeks after D-Day, tank commanders now led aggressive charges, bursting through the barriers at speed and catching German defenders by surprise. Lieutenant Colonel Creighton Abrams, commanding the 37th Tank Battalion, pioneered what became known as the Thunder Run, a rapid advance through multiple hedgerows with minimal pause between breaches. This tactic prevented German anti-tank teams from repositioning and created a psychological shock effect that often led to enemy retreat or surrender. "The key," Abrams explained to his company commanders, "is continuity of movement. Don't give them time to think or reposition. Hit one hedgerow, then the next, then the next. Create the impression of unstoppable momentum." These tactics proved devastatingly effective. During Operation Cobra, which began on July 25th, Abrams' battalion advanced 7 miles in a single day, a distance that would have taken weeks to cover in the early hedgerow fighting. Similar results were reported across the American sector as Rhino-equipped tanks spearheaded the breakout from Normandy. The hedgerow solution also highlighted the crucial relationship between American industrial capacity and battlefield innovation. While the initial Rhino devices were improvised from salvaged materials, the U.S. Army's supply system quickly began manufacturing purpose-built cutting attachments in England and shipping them to Normandy. By early August, newly arriving Sherman tanks came equipped with factory-installed hedgerow cutters, the design having been transmitted back to production facilities in the United States and implemented on the assembly line. This rapid integration of battlefield lessons into the production process demonstrated an institutional agility that German manufacturing, despite its technical excellence, could not match. The contrast with German innovation was stark. The German military had developed its own solutions to specific battlefield challenges, such as the addition of concrete armor to tanks on the Eastern Front, or the creation of the Sturmgeschütz assault gun to provide infantry support. But these innovations typically took months or years to implement at scale, by which time tactical conditions had often changed. Colonel Wilhelm Sievers of the German 352nd Infantry Division, captured during the American breakout from Normandy, expressed his frustration during interrogation. "We identified the same hedgerow problem in 1940 when we first occupied this region. Our engineers submitted designs for specialized breaching vehicles, but 4 years later, we were still waiting for them to arrive from the factories. Meanwhile, you Americans solved the problem in weeks. The rapid adoption of the Rhino tank modification accelerated the Allied advance across Normandy in ways that transformed the strategic picture. By late July, American forces had broken through the Bocage country and reached the open terrain beyond, where their advantages in mobility and air power could be fully leveraged. The German defense, which had been tenacious and effective in the hedgerow country, began to collapse once this natural fortress was breached. Operation Cobra, launched on July 25th, marked the definitive end of the hedgerow stalemate, preceded by a devastating carpet bombing by over 1,500 Allied aircraft. The operation saw 3 American corps burst through the German lines near Street Low. Leading the advance were hundreds of Rhino-equipped Sherman tanks, now able to move across the landscape without being channeled by the once impenetrable hedgerows. The operation achieved a decisive breakthrough. Within a week, American armored columns had advanced nearly 40 miles, reaching Avranches at the base of the Brittany Peninsula and threatening to encircle the entire German 7th Army. What had been a grinding war of attrition suddenly transformed into a war of movement, exactly the type of warfare that American doctrine and equipment had been designed to win. General George S. Patton's Third Army, which became operational on August 1st, exploited this breakthrough with characteristic aggression. Patton's forces, equipped with the latest factory-built Rhino tanks, swept across Brittany and turned eastward toward the Seine River, moving at speeds that would have been unimaginable during the hedgerow fighting of June and early July. "The hedgerows nearly broke us," Patton reportedly told his staff as they reviewed maps showing the rapid advance. "But we broke the hedgerows instead, and now nothing stands between us and Germany." The German High Command, which had counted on the Bocage country to delay the Allied advance for months, found itself facing a strategic disaster. Field Marshal Günther von Kluge, commanding German forces in Normandy, sent an urgent message to Hitler on August 4th. "The Americans have solved the hedgerow problem and are now advancing at speeds we cannot counter. Without immediate reinforcement, total collapse is inevitable." Hitler's response was to order a counterattack toward Avranches, aimed at cutting off Patton's advancing Third Army from its supply lines. This attack, launched on August 7th near Mortagne, represented the last significant German offensive in Normandy. It was quickly contained by American forces, and in its aftermath, the German position in Normandy became untenable. By mid-August, American and British forces had encircled large elements of the German army near Falaise. Though some German units escaped the Falaise pocket, they left behind most of their heavy equipment. The German 7th Army and 5th Panzer Army suffered losses from which they would never recover. Over 10,000 killed, 50,000 captured, and nearly all their tanks and artillery destroyed or abandoned. The hedgerow breakthrough had not just accelerated the Allied advance, it had created the conditions for a decisive victory that effectively ended the battle for Normandy and opened the way to Paris and the German border beyond. What had begun as a simple mechanical innovation by a sergeant from Chicago had transformed the entire Western Front. For the men who had fought and died in the early hedgerow battles, the Rhino tanks came too late. Thousands of American soldiers had been lost in the bloody fields of the Bocage during June and early July, their sacrifice a grim testimony to the cost of tactical surprise and inadequate preparation. Lieutenant David Wilson of the 29th Infantry Division, who had fought through the hedgerows both before and after the introduction of the Rhino tanks, captured this bitter irony in a letter home dated August 10th. The fields we now drive through in minutes are the same ones where we lost half my platoon in June. I keep thinking about how many would still be alive if we'd had these modified tanks from the beginning. The lesson was not lost on Allied commanders. General Bradley, in particular, became a passionate advocate for bottom-up innovation and rapid adaptation to battlefield conditions. In a directive issued to all commanders under his First Army on August 15th, he wrote, "The solution to the hedgerow problem came not from headquarters, but from the men facing the problem directly. This pattern must be encouraged and supported at all levels of command." The success of the Rhino tanks influenced American military thinking well beyond the Normandy campaign. It reinforced the value of field modification, rapid prototyping, and empowering frontline soldiers to develop tactical solutions. This approach would pay dividends again in later campaigns, from the Rhine crossings to the Pacific Island assaults. As American forces pushed beyond Normandy and into the heart of France, they encountered new challenges that called for similar innovation. When Sherman tanks proved vulnerable to German Panzerfaust anti-tank weapons in urban fighting, crews developed sandbag armor, literally hanging sandbags on their vehicles to detonate shaped charge weapons before they could penetrate the main armor. When winter conditions in the Ardennes during the Battle of the Bulge caused tank tracks to lose traction on icy roads, maintenance units developed improvised cleats welded to track sections. Like the Rhino devices before them, these innovations spread rapidly through the ranks, often becoming standardized before formal approval processes could even begin. The hedgerow breakthrough also highlighted a fundamental difference in problem-solving approaches between American and German forces. German military tradition emphasized thorough planning, extensive testing, and centralized approval, an approach that produced excellent results when time permitted but proved too slow for the rapidly changing conditions of modern warfare. American forces, by contrast, embraced what would later be called fail-fast methodology, trying multiple solutions quickly, accepting that many would fail, but ensuring that successful innovations could be rapidly identified and implemented. This cultural difference proved as significant as any technological or numerical advantage. Colonel Thornton, who had recognized the hedgerow problem before D-Day but been unable to develop a pre-invasion solution, reflected on this lesson in a report to the War Department dated September 1944. The American soldier brings to the battlefield not just his weapon but his entire background, his experience fixing farm equipment, working in factories, solving practical problems. This national characteristic may be our most significant military asset. For Sergeant Curtis Culin, the creator of the original Rhino device, the aftermath of his innovation brought unexpected recognition. Summoned from his unit in late July, he found himself shaking hands with Generals Eisenhower, Bradley, and Patton, all of whom wanted to personally thank the man whose idea had broken the hedgerow stalemate. Eisenhower awarded Culin the Legion of Merit, an unusually high decoration for a non-commissioned officer, and asked what had inspired his solution. Culin's response was characteristically straightforward. "I was just tired of seeing our boys get killed in those damn hedgerows." Sometimes, the simplest ideas work best. The Supreme Allied commander reportedly turned to his assembled staff and said, "This is why Hitler will lose. He has better tanks than we do, but we have better men in our tanks." Tragically, Culin himself would not see the final victory his innovation helped secure. In August 1944, while demonstrating the Rhino device to newly arrived tank crews, he was seriously wounded when his tank struck a German mine. Though he survived, his injuries ended his combat service, and he was evacuated to England and later the United States. Before leaving the European theatre, Culin had the opportunity to see how thoroughly his improvised solution had been adopted. By September 1944, nearly every Sherman tank in the American inventory sported some version of his hedgerow cutter. The device had been refined, standardized, and was now being factory installed on new tanks arriving from the United States. What had begun as scrap metal welded to a single tank on the front lines of Normandy had become standard equipment for the most numerous tank in Allied service. It was, perhaps, the most rapid cycle from battlefield innovation to standard doctrine in modern military history. As American forces pushed toward Germany in the fall of 1944, they carried with them not just the physical manifestation of Culin's innovation in the form of Rhino-equipped tanks, but also the less tangible but equally important lesson it represented, that adaptability, innovation, and individual initiative could overcome seemingly insurmountable obstacles. The German defenders they faced, though still dangerous and determined, were increasingly outmatched not just in numbers and material, but in the crucial realm of tactical adaptation. Where American forces embraced field modifications and improvisation, German units remained bound by rigid doctrine and centralized control. This contrast was noted by Major General Maurice Rose, commanding the 3rd Armored Division, in a report filed in October 1944. The German is an excellent soldier when fighting according to his training and with equipment as designed. But when conditions change or equipment fails, he lacks the initiative we take for granted in our troops. The Hedgerow story exemplifies this difference perfectly. The success of the Rhino tanks and the breakout from Normandy brought American forces to the threshold of Germany by September 1944. The rapid advance had surprised even the most optimistic Allied planners, creating both opportunities and new challenges. As tanks that had fought through the hedgerows now approached the German border, the lessons of adaptive innovation that had made this progress possible were being institutionalized throughout the American military. At the Pentagon in Washington, D.C., the story of the Rhino tanks had captured the imagination of military planners and industrial leaders alike. What had begun as a sergeant's improvisation was now being studied as a case example of American ingenuity and battlefield adaptation. General George Marshall, Army Chief of Staff, convened a special committee in August 1944 specifically to identify similar innovations from the front lines and accelerate their adoption. The hedgerow breakthrough wasn't just about a mechanical solution, Marshall told the assembled officers and civilian experts. It was about a process, how we identify problems, generate solutions, test them under fire, and implement the successful ones rapidly. This process may be more valuable to our war effort than any single weapon system. The committee, formally designated the Combat Innovations Group, but quickly nicknamed Culin's Committee, after the sergeant who had created the Rhino device, brought together an unusual mix of personnel. Combat-experienced officers served alongside industrial engineers, automotive designers, and even civilian inventors. Their mandate was simple but revolutionary: find ways to systematically harvest good ideas from the front lines and turn them into standard equipment and doctrine as quickly as possible. Colonel Richard Mower, appointed to head the committee, had served as an artillery officer in North Africa and Sicily before being wounded and reassigned to Washington. His first action was to establish direct communication channels with frontline units, bypassing traditional command structures. "We need to hear directly from the men facing these problems," he explained to his skeptical superiors. "The normal reporting chain filters out too much crucial information, especially from lower ranks where the most practical solutions often originate." The results were immediate and impressive. Within weeks, the Normandy committee was receiving hundreds of suggestions per month, everything from minor modifications to existing equipment to entirely new approaches to battlefield challenges. Each was evaluated, the promising ones tested, and the successful solutions pushed into production and distribution with unprecedented speed. Meanwhile, in Europe, the practical impact of the hedgerow breakthrough continued to reshape the war. The liberation of Paris on the 25th of August 1944, just 2 months after D-Day, had been made possible by the accelerated timetable that followed the Bocage breakout. American forces that had been expected to spend the summer bogged down in Normandy were instead racing across France toward the German border. Lieutenant General George S. Patton's Third Army exemplified this new momentum. Released from the constraints of hedgerow country, Patton's forces advanced over 400 miles in a month, liberating much of central and eastern France, while inflicting catastrophic losses on retreating German units. The speed of this advance created its own challenges, particularly in logistics, but these too became opportunities for American innovation. The Red Ball Express, an improvised truck convoy system created to supply the rapidly advancing American armies, became another example of American adaptability. When existing supply systems proved inadequate for the pace of advance, transportation officers established a one-way circular route with thousands of trucks running continuously to deliver fuel, ammunition, and supplies to the front. At its peak in late August, the Red Ball Express operated nearly 6,000 trucks and delivered over 12,000 tons of supplies daily, often to units that had advanced so rapidly their positions weren't even on the driver's maps. Like the Rhino tanks before it, the Red Ball Express represented American problem-solving at its most practical and effective. Colonel John Walsh, who commanded a transportation battalion supporting Patton's advance, later recalled, "We were making it up as we went along, but that's what Americans do best. We had the trucks, we had the fuel, we had motivated drivers. The rest was just logistics and determination." Back in Normandy, where the story had begun, a different kind of innovation was taking place. Engineers and recovery teams were studying the battlefields of the hedgerow country, documenting the lessons learned and recovering valuable equipment. Among them was Major Robert Calloway, the engineering officer who had recognized the hedgerow problem before D-Day but had been unable to solve it in time. Walking through the fields near Street, low on a crisp September morning, Calloway stopped at a Sherman tank that had been knocked out in the early fighting. Its hull was still blackened from the fire that had consumed it, the turret thrown clear by an internal explosion. Next to it stood another Sherman, this one equipped with the now familiar Rhino device, apparently abandoned after mechanical failure rather than enemy action. "Two chapters in the same story," he remarked to Captain Howard Lewis, who accompanied him on the survey. "This first one represents our failure to anticipate and prepare. The second shows how we recovered and adapted." Lewis, who had served as a liaison between combat units and engineering support during the hedgerow fighting, nodded in agreement. The real question is whether we've truly learned the institutional lesson. Will we be better at anticipating the next challenge, or will we always be solving problems after they've already cost us lives? It was a profound question that would resonate through the remaining months of the war and beyond. The American military had demonstrated remarkable ability to adapt to unforeseen challenges, but could it develop the foresight to identify and solve problems before they manifested on the battlefield? Evidence suggested a transformation was already underway. In September 1944, as Allied forces approached the German border, intelligence reports warned of extensive fortifications along the Siegfried Line, or West Wall, as the Germans called it. Rather than waiting to discover the exact nature of these defenses through costly direct experience, American planners launched a comprehensive preparation effort. Aerial reconnaissance photographed the fortifications in detail. German prisoners familiar with the defenses were intensively interrogated. Engineers constructed mock-ups of the concrete, dragon's teeth, anti-tank obstacles and bunker systems for tank crews to practice against. Most importantly, frontline units were encouraged to develop and test breaching methods before they actually encountered the real fortifications. The result was a striking contrast to the hedgerow experience. When American forces reached the Siegfried Line in late September, they came equipped with specialized demolition techniques, modified tanks with bulldozer blades now nicknamed Dozervilles, after their creator, Sergeant Harry Dozersville of the 81st Engineer Combat Battalion, and tactical doctrines specifically designed for breaching fortified lines. The fighting along the Siegfried Line was still difficult and costly, as any assault against prepared defenses must be, but it lacked the disastrous surprise and improvisation under fire that had characterized the early hedgerow battles. The lesson of the Rhino tanks had been institutionalized: identify problems early, develop solutions methodically, and implement them before they cost unnecessary lives. For Sergeant Curtis Cullen, the originator of the Rhino device, the war had taken a personal toll. After being wounded in August 1944, he had been evacuated to a hospital in England and then back to the United States. His injuries, while not life-threatening, were severe enough to end his combat service. By October, he was recovering at Walter Reed Hospital in Washington, still unaware of the full impact his innovation had made on the European campaign. That changed on October 18th when General Marshall himself visited the hospital to check on wounded personnel. Recognizing Cullen's name from the now famous hedgerow modification, Marshall made a point of visiting his room personally. "Sergeant," the Chief of Staff said as he entered, "I wanted to thank you in person for what you did in Normandy. Your innovation not only saved countless American lives, but significantly accelerated our timetable for the liberation of Europe." Cullen, still weak from his injuries and overwhelmed by the presence of the Army's highest-ranking officer, managed a respectful response. "Sir, I just saw a problem that needed fixing. Any of our boys would have done the same if they'd thought of it first." Marshall nodded thoughtfully. "That's precisely what makes your contribution so valuable, Sergeant. Not just the device itself, but what it represents about American soldiers. The initiative, the practical problem-solving, the willingness to try new approaches under the most difficult circumstances. These qualities are as important to our war effort as any weapon or strategic plan." Before leaving, Marshall informed Cullen that his story was being used as a case study at the Command and General Staff College, where future officers were being taught the importance of encouraging and implementing innovations from all ranks. The Rhino tank had become not just a tactical solution, but a symbol of American military philosophy. As the European campaign progressed into the difficult fighting of late 1944 and early 1945, the lessons of the hedgerow breakthrough continued to influence American operations. The Battle of the Bulge in December 1944, Hitler's last desperate offensive in the West, tested American adaptability in new ways, as German forces achieved tactical surprise and initially pushed back Allied lines. The situation was critical, with German armoured columns threatening to split the Allied forces and potentially recapture the crucial port of Antwerp. Yet even in this crisis, the spirit of innovation that had solved the hedgerow problem manifested in new forms. When fuel shortages threatened to ground tactical aircraft that were crucial for locating and attacking German columns, maintenance crews developed methods to modify fighter engines to use lower-grade fuel. When roads became impassable due to snow and ice, engineers improvised cleats for tank tracks using scrap metal. When communications were disrupted by German infiltration, signal units created new radio protocols and improvised relay stations to maintain command and control. These innovations, none as dramatic as the original Rhino tanks but collectively just as important, helped American forces weather the initial German onslaught and eventually turn the tide. By late January 1945, the Bulge had been eliminated, and Allied forces were once again advancing toward Germany. Back in Washington, Cullen's committee had expanded its scope beyond equipment modifications to encompass tactical innovations, training methods, and even psychological operations. The committee's work had gained such prominence that industrial leaders from across America were volunteering their company's research and development resources to test and implement promising ideas from the front. Henry Ford II, who had taken over Ford Motor Company after his father's retirement, visited the committee in January 1945 and was particularly impressed by its approach. "This is how we work in the automotive industry," he told Colonel Mower. "We listen to the mechanics in the garages and the drivers on the road, not just the engineers in the design office. The best innovations come from people who face the problems directly." Ford offered the resources of his company's engineering department to evaluate and refine battlefield innovations, an offer that was quickly accepted. Similar partnerships were established with other industrial giants, creating an unprecedented collaboration between the military and civilian sectors. As Allied forces crossed the Rhine River in March 1945 and pushed into the German heartland, they encountered new challenges that called for further innovation. Urban combat in German cities required specialized tactics and equipment. The Sherman tanks that had broken through the hedgerows of Normandy now needed modifications to operate effectively in narrow streets and against buildings being used as fortifications. Tank commanders developed techniques for urban fighting that minimized their vehicles' vulnerabilities while maximizing their firepower. Engineers created demolition packages that tanks could deploy to breach walls and barricades. Infantry and tank units practiced combined operations specifically designed for city fighting. These adaptations, while less visible than the distinctive Rhino devices, were equally important to the final Allied victory. By April 1945, American forces had penetrated deep into Germany, and the Third Reich's collapse was imminent. On the 8th of May 1945, less than a year after D-Day, Germany surrendered unconditionally. In the aftermath of victory, military analysts began the process of studying the European campaign to extract lessons for future conflicts. The story of the Rhino tanks and the hedgerow breakthrough featured prominently in these assessments, not just as a tactical success, but as a case study in military innovation and adaptation. General Omar Bradley, in his final report as commander of the 12th Army Group, dedicated an entire section to battlefield innovation and adaptation. He wrote, "Perhaps the most significant American advantage in this war was not our industrial capacity or numerical superiority, but our cultural and institutional ability to identify problems, develop solutions, and implement them rapidly under combat conditions. The hedgerow episode exemplifies this advantage perfectly. For the men who had fought through the Bocage and beyond, the lessons were more personal and immediate. Captain Thomas Blackwell, who had commanded a tank company through the entire campaign from Normandy to Germany, expressed it simply in a letter home, dated the 12th of May 1945. We won because we adapted faster than they did. When we hit those hedgerows and started losing tanks and men, we could have resigned ourselves to a slow, bloody advance. Instead, we figured out a better way. That's what Americans do." The Rhino tanks themselves, once so crucial to the campaign's success, had largely disappeared by the war's end. As American forces moved beyond Normandy into terrain where the specialized hedgerow cutting devices were no longer needed, many were removed to reduce weight and improve maneuverability. By the time American tanks reached Germany, few still carried the distinctive tusks that had broken the Bocage stalemate, but the spirit of innovation they represented had become permanently integrated into American military doctrine. When the Army established the Operations Research Office in 1948 to systematically study combat effectiveness and equipment design, many of its founding principles derived directly from the lessons of the Rhino tanks and similar wartime innovations. Sergeant Curtis Culin, the originator of the Rhino device, returned to civilian life after recovering from his wounds. He rarely spoke about his wartime innovation, preferring to focus on rebuilding his life like millions of other veterans. When occasionally asked about it, he typically downplayed his contribution, insisting that he had simply been in the right place at the right time with the right idea. In 1954, however, Cullen agreed to an interview for an Army historical study of the Normandy campaign. Asked what he considered the most important lesson of the hedgerow breakthrough, his answer was characteristically straightforward. "Trust your people. The generals and colonels have the big picture, but the sergeants and privates have their boots on the ground. Sometimes the simplest solutions come from the folks facing the problem every day." This philosophy, that good ideas can come from anywhere in an organization, regardless of rank or position, transcended its military origins to influence American business, education, and civil governance in the post-war era. Companies like Ford, General Electric, and IBM explicitly incorporated lessons from wartime innovation into their management practices, creating more open channels for employee suggestions and faster implementation of promising ideas. In military circles, the hedgerow story became standard curriculum at service academies and officer training schools. At West Point, instructors used it to emphasize that effective leadership meant not just giving orders, but creating conditions where innovation could flourish at all levels of command. Colonel James Thornton, who had recognized the hedgerow problem before D-Day but been unable to solve it in time, became one of the most passionate advocates for this approach. After retiring from active service in 1952, he accepted a position teaching military history at West Point, where he used his first-hand experience with the Bocage campaign to illustrate the critical importance of adaptive leadership. The lesson of the hedgerows isn't just about tanks or terrain, he told his students. It's about humility and openness. Sometimes the best solution comes from the lowest-ranking person in the room. Your job as leaders is to create an environment where that person feels empowered to speak up, and where good ideas can be recognized and implemented regardless of their source. This philosophy represented a significant evolution in military thinking. Traditional military hierarchies emphasized top-down authority and strict adherence to established doctrine. The lessons of the Rhino tanks and similar innovations suggested a more balanced approach, where command authority was complemented by bottom-up problem-solving. As the Cold War emerged and the American military prepared for potential conflict with the Soviet Union, this adaptive mindset proved invaluable. Soviet forces held advantages in numbers and often in equipment specifications, but American military planners believed their edge in tactical flexibility and innovation would prove decisive in any actual conflict. The story of how American engineers solved the Bocage Hedgerow problem transcended its specific historical context to become a broader parable about American ingenuity and adaptability. It demonstrated that in the most challenging circumstances, facing obstacles that seemed insurmountable, the combination of practical problem-solving, openness to ideas from all sources, and rapid implementation could overcome even the most formidable barriers. The ancient hedgerows of Normandy, which had nearly stalled the Allied advance and threatened the entire liberation of Europe, were defeated not primarily by overwhelming force, but by an improvised innovation from a sergeant who saw a problem and decided to solve it. In that simple act, and in the system that recognized and implemented his solution, lay a profound lesson about how challenges are overcome and victories achieved on battlefields and beyond. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.